I've talked to you already about the ultrasound beam and emphasized that it's very important to the quality of the image. The better the beam can be focused, the higher the image resolution. There is, however, another aspect to the beam, and that is the fact that it has imperfections. The beam is not just a single beam, and it has a thickness dimension to it as well. So let's look briefly at these two things. Here we have a graph of the beam profile, which means a graph of the distribution of ultrasound intensity across the beam at one particular depth, for example at the focal depth. So here on the left we can see that the intensity is maximum in the center of the beam and it falls to zero at the edges of the beam. Notice, however, that there are little bumps outside of the main beam, which we refer to as side lobes. So this is unwanted energy being directed in other directions, not within the main beam. This is an unfortunate fact that when you focus any kind of wave energy at all into a beam, there will be side lobes as well. To make the side lobes more evident, on the right, I have plotted the profile, the exact same profile, but using a logarithmic scale, which emphasizes the low-level side lobes relative to the main beam. Importantly, there are two things we can see. There are multiple side lobes, and they are quite weak compared to the main beam. In particular, the first side lobe either side of the main beam is approximately 20 decibels, or a factor of 100, times weaker than the main beam. So the side lobes are 20 decibels or more below the main beam in their intensity. Nevertheless, there are times when you have a very strong reflector that can be seen by the side lobes. In other words, the lower level energy transmitted by the side lobes and the fact that the side lobes can receive echoes, it may be enough to produce detectable echoes which will be displayed in the image. The machine has no way to tell that these echoes have come from side lobes, so it will display them as if they've come from the main beam, which means they'll be displayed in the wrong place. So side lobe artifacts are an important artifact in ultrasound images in some situations. Here we have another aspect of the beam. I've drawn here a diagram of the transducer. I've highlighted the aperture in green again, as I did in the previous talk. And I've shown the scan plane running the length of the transducer, and then another plane at 90 degrees to the scan plane, which I've labeled the elevation plane. The reason for this diagram is that we have to think about the ultrasound beam is a three-dimensional thing. Normally, we're looking at the ultrasound beam as it is projected into the scan plane. So we're looking at its dimensions within the scan plane. But it's important also to be aware that it has a third dimension, which we would describe as being the elevation plane beam profile. So let's think about how well focused the beam is within this elevation plane compared to its focusing within the scan plane. Now the frequency is the same, the depth is likely to be similar, so the only thing that's really different is the size of the aperture, the active area on the face of the transducer that's producing the beam. And what you can see is that the aperture within the scan plane is much larger than the aperture within the elevation plane, because the transducer is much longer than it is wide. And this is going to affect how well the beam can be focused. The beam can focus pretty well within the scan plane because of the larger aperture. It focuses less well in the elevation plane because of the smaller aperture. This shows us a beam focused at a depth of 5 centimeters with typical dimensions for a 5 megahertz probe. So we might have a 20 millimeter or 2 centimeter aperture within the scan plane. So that's along the length of the transducer, producing a nice tight focus at the focal depth of 5 centimeters. But if we now think of the transducer width as being around 7 millimeters, operating at the same frequency, attempting to focus at a depth of 5 centimeters, we find that actually it's not possible to focus properly at that depth with such a small aperture. And so the beam is much less well focused in this slice thickness direction, and therefore this will have a significant impact on the image quality. So we'll talk later on about image artifacts, and I'll talk about slice thickness artifact at that point. So I've just spoken very briefly about imperfections of the ultrasound beam, or important aspects of the ultrasound beam that are perhaps not evident at first. So we looked at the beam profile and the presence of side lobes, the fact that these can produce side lobe artifacts in images. And then I discussed the elevation plane, or slice thickness dimension of the ultrasound beam, and the fact that this is not well focused, the beam is not so well focused in this dimension, leading to the possibility of slice thickness artifact in the image. And I'll speak about these artifacts later.